Hey everyone, thanks for tuning in. Today we'll be looking at the trigonometric identities. Now these will be useful for solving a variety of trigonometric equations, as well as being used in proofs of trigonometric equations. Now if you need some practice with this sort of stuff, please refer to my other videos of how to actually use these identities, and those links will be provided in the description. For this lesson, we will just be looking at the identities themselves. So first off, we look at the reciprocal identities. So these reciprocal identities, there's three of them that we need to remember. And the first one is cosec theta. And we say cosec theta is equal to 1 over sine theta. We define sec theta as 1 over cos theta. And we define cot theta as 1 over tan theta. So we can see why we call them the reciprocal functions, because they are equal to, well, the reciprocals of sine theta, cos theta, and tan theta. Now, a nice easy way to remember this is to pay attention to the third letter of each of them. So as we can see, we have the third letter of cosec is S to represent the reciprocal function of sine. We have the third letter of sec theta is a C to represent the reciprocal function of cos. And finally, the third letter of cot theta is T to represent the reciprocal of tan theta. Okay, so these are nice and easy to remember. Now the next set of identities that we look at are the ratio identities. So these, quite simply, there's just two of them. And the first one we look at is tan theta is equal to sine theta over cos theta. Okay, there's no real easy way to remember this. Okay, we just got to kind of bite the bullet on this a little bit and just, remember it, I guess. Then we define cot theta as cos theta over sine theta. Now, as you can see, as you should remember rather, cot theta is the reciprocal of tan theta. Okay, which should make sense in defining these identities, because we've defined tan theta as sine over cos. So what do we do to define cot? Considering it's the reciprocal function of tan, we just flip the fraction. So here we have sine over cos, and when we flip that fraction, we end up with cos over sine. Okay? So right here, we've got 5 trigonometric identities. Now there are a few more identities we look at, namely the Pythagorean identities. Okay, so we define the first Pythagorean identity as sine squared theta plus cos squared theta equals 1. Now this is probably your most important identity that you will have to use. And from this, we can get 2 more equations. Namely, if we divide every term by cos squared theta. So I'll just make a comment here, dividing by cos squared theta. So if we divide by cos squared theta, what's sine squared theta divided by cos squared theta? Well, we've defined, just previously, we defined that sine theta over cos theta was equal to tan theta. So that means sine squared theta over cos squared theta is going to be equal to tan squared theta. So we get tan squared theta. We're dividing by cos squared theta. So cos squared theta divided by cos squared theta, well, that should be 1. And that's equal to 1 divided by cos squared theta. Now remember, 1 over cos theta is sec theta. So that means 1 over cos squared theta is going to be sec squared theta. So this is another identity that we get, okay, by dividing by cos squared theta. Alternatively, we can come up with another Pythagorean identity, and it's if we are dividing by, instead of cos squared theta, now this time we want to divide by sine squared theta, okay? So we're dividing this equation up here by sine squared theta. And, well, what's sine squared theta divided by sine squared theta? That should be 1. What's cos squared theta divided by sine squared theta? Well, we defined previously that cos theta over sine theta, right here, was equal to cot theta. So that means cos squared theta divided by sine squared theta is going to be cot squared theta. And that's equal to 1 divided by sine squared theta, and that's going to be cosec squared theta. So these are our 3 Pythagorean identities that we need to remember. Okay. The final, I guess, identities that we can call them are the complementary angles. So the complementary angles are defined by these sets of identities here. Now, why are they called complementary angles? Well, recall the definition of complementary. Complementary means 2 angles which sum to 90 degrees. And as we can clearly see here, we have we're relating 2 angles which sum to 90 degrees. Now, we define sine of 90 minus theta is equal to cos. And this works in the reverse way, in that cos of 90 minus theta is equal to sine. So as we can see, sine and cos relate to each other quite heavily. The next one that we look at is that tan 90 minus theta is equal to cot theta, and that cot 90 minus theta is equal to tan theta. So what we can see here is that tan and cot relate to each other, and sine and cos relate to each other. And once you got this, basically you can get the last 2 quite easily, mainly because it's a direct derivation of the first 2. So as we can see, we've just reciprocated this one. So sine 90 minus theta equals cos theta. If we use the reciprocal identities, what we can see is that cosec 90 minus theta is equal to sec theta. Because remember, cosec with the s relates to that sine, and the sec of the cos relates to the cos. And obviously this works in the reverse direction, in that sec 90 minus theta is equal to cosec theta. These are all the relevant identities that you will need to know. So there's not too many. So we've got the complementary angles, we've got the Pythagorean identities, and we've got the trigonometric, the reciprocal and the ratio identities. Okay. I hope this helped. Please refer to my other videos if you need help with actually using these identities. Okay, and with that, I'll leave you guys to it. Have a good day.